Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics and specifically the topic of transformations. We'll be looking at the past paper solutions from May 2009 until 2013. Feel free to like the video and add any comments down below so we can create other videos to help you in any areas that you are struggling with. Don't forget to look at the description down below, where we have outlined the entire CSEC Maths syllabus and the order we recommend for you to go through the videos in order to get a better grasp of this area. Let's recall the 10 major topics in CSEC Mathematics, and we'll be looking at topic number 8, Geometry and Trigonometry. This area is tested for 8 questions out of the 60 in paper 1, the multiple choice, and 21 marks out of the 100 in paper 2. This area can be split into 2 parts, into geometry or trigonometry. And within geometry itself, that can be subdivided into circle geometry, unknown angles, geometric construction, and transformation. So in this video, we'll be looking at transformation. From 2009 until 2013, this topic came in 4 of the 5 past papers. May 2009, number 6. The diagram below shows triangles A, B, and D. The line y equal to x is also shown. Part A. Describe fully single transformation which maps triangle A onto triangle D. So if we take a look at triangle A, let's bring it up. And how does it go onto triangle D? We can see it slides across. At our level, we'll be using the word translation. Are the same. And how much did it slide? When we're describing that translation movement, what we want to look at is how much it slid to the right or left in the x direction, and then how much it slid up or down in the y direction. So we can see that it moves 1, 2, 3 units to the right. It moved 1, 2, 3, 4 units up. So this has been indicated by the purple arrows. So it's 3 to the right means it's plus 3, and it's 4 up, so it's plus 4. So we write it, translation, 3, 4. Describe fully the single transformation which maps triangle A onto triangle B. So let's look at triangle A, and how will it move onto triangle B? Well, it's not a translation, it didn't slide. It's not a reflection, it's not an enlargement. It looks like it turns. So the proper name for that is rotation. So triangle B, for it to get there, that's the object. It started at triangle A, that's the image. Then it rotated, and our triangle rotates, and we see our yellow line turning as well. So that means it turns about the center, and the center there is the origin O, which is 0, 0. And it turned how many degrees? We can see if we use our geometry set and look at our triangle, one of the set squares in there, one of the triangles in there, and put it, we can pick up the 90 degrees, or we can measure with our protractor, and we can see that it turned 90 degrees in a clockwise direction. So in order to get the 3 marks, we need to have these pieces of information. What type of transformation it is? It's a rotation, and the center of rotation is at the origin, and the angle is 90 degrees in a particular direction, in a clockwise direction. And for the last part of the question, part B, state the coordinates of the vertices of triangle C, the image of triangle A, after reflection in the line y equal to x. So let's look at triangle A, and if it's reflecting about that line, it means that it's being folded across that line, or it flips. Let's bring up our light pink triangle to show the reflection. So we can see that it's equidistant from that line. It's equal distance on either side of the y equal to x line, each vertice. So what are the vertices of this new triangle, triangle C? 1, 2, 1, 5, and 3, 5. May 2010, number 6b. The diagram below shows triangle LMN, which is on the right-hand side, and its image L prime, M prime, N prime on the left-hand side after undergoing a rotation. Describe the rotation fully by stating the center. And we can see as the pink triangle came up with its yellow arm, and the arm turns, it turns about the origin. So the center of rotation is the origin, 0, 0, which can be written as a column vector coming down or going across as a row vector. The angle of rotation is 90 degrees, and the direction of rotation is counterclockwise or anticlockwise. Part 2. State two geometric relationships between triangle LMN and its image triangle L prime, M prime, N prime. So if we look at the two shapes, the object and its image, they both have the same sides, their lengths, and the same angles. So we can say they are congruent to each other. And also, each one of the sides, such as LN, that was vertical, and after the rotation, L prime, N prime, that became horizontal. MN on the right-hand side was horizontal. When it rotated, it became vertical. So we can see the sides of the object are perpendicular to the corresponding sides of the image. Part 3. Triangle LMN is translated by the vector 1 minus 2. If it's translated, it means that it slides 1 to the right and 2 down. So if we move L and we slide it to the right with the purple arrow, 1 place, it will move from 1 to 2. And then slide 2 down, so it will end up on M. So after the translation, L went to its new point, L double prime, which is exactly where M is, at 2, 1. So we can determine the coordinates by another method where we can write a formula. L, that's the point, plus the translation vector T will give us our new point, L double prime. And we can substitute. L is 1, 3. And T is 1 minus 2, so it's better to write these as column vectors rather than row vectors. And when we do the addition of vectors, we can say 1 plus 1 is 2, 3 plus minus 2, well, a plus and a minus, two different signs will be a minus, so 3 take away 2 is 1. So L double prime is 2, 1, which is actually where M is. May 2012, number 6. The graph below shows triangle LMN, which is a smaller triangle, and its image PQR, the larger triangle. Locate the center of enlargement, showing your method clearly. If it's moving from the small triangle downward to the right, it means that the center of enlargement is somewhere up on the left-hand side. So how do we find this? We know L, when it was enlarged at that point, moved to P. M moved to Q, and N moved to R. So let's connect L and P. So let's draw a line from the right to the left, passing through P and L. And let's do the same thing from R to N, and we can see they intersect at a point 1, 5. So this point of intersection will be our center of enlargement. And 2 lines are enough, but if you want to be safe, you can draw a third line through QM, and you'll see all 3 points meet at the same place. Part B, state the scale factor and the coordinates of the center of enlargement. If we look at the length of LM, it's 3 units. And when it's enlarged, it became 1, 2, 3, 4, 5, 6 units. So it became twice as big. Even the horizontal line MN was 2 units. And when it moved to QR, it became 4 units. So it became twice as big. As such, the scale factor, which is normally represented as K, is equal to 2, meaning it got twice as big. And what are the center coordinates for the enlargement? The points met at 1, 5, which can be written as a column vector or a row vector. Part C, determine the value of the area of triangle PQR over the area of triangle LMN. So there are a couple of ways to do this. One way would be to find the area of the larger triangle PQR. And area of a triangle is length by breadth all over 2. Remember, length by breadth gives you an area of a rectangle. And if we cut a rectangle in half, we divide by 2, you'll get the area of a triangle. And that will give us 4 by 6 all over 2. 4 6 are 24, 2 into 24, 12. Area of a triangle, LMN, is similar formula, and we substitute 2 times 3 over 2. 2 cancels 2, so we're left with 3. So if we look at the division, the ratio between area of PQR and the area of LMN will be 12 over 3, which is 4. But there's another way to do it, which is much quicker. The change in area is really whatever the scale factor is squared. So in this case, the scale factor K is 2, so it's 2 squared is 4. Why that is the case? Because the width gets twice as big and the height gets twice as big. So 2 by 2 is 4. If the scale factor was 3, then the change in area will be 3 squared, which means it'll get 9 times larger, the area. Part D. Draw and label triangle ABC with coordinates minus 4, 4. Let's bring up that point. That's A. Minus 1, 4. That's B. And minus 1, 2, respectively. And let's connect them and put up our blue triangle. Part E. Last part of the question. Describe fully the single transformation which maps triangle LMN, a small triangle, onto triangle ABC. We can clearly see to move from the small triangle on the right hand side to the left side that it is a rotation. So let's bring up our arm and show the rotation, and we can see that as it rotated, it moved about the center of enlargement at the origin, 0, 0, and it moved an angle of 90 degrees in an anti-clockwise direction. May 2013, number 6b. The graph below shows triangle LMN, which is on the left-hand side, and this image L prime, M prime, N prime, which is on the right-hand side, after undergoing a single transformation. Describe fully the transformation that maps triangle LMN onto triangle L prime, M prime, N prime. So we can see that it moved from the left to the right by a flip or a reflection about a line, and we need to figure out where that line is. So the easiest way to get that line, let's connect M to where it was reflected to, M prime, with a blue line, and let's do the same thing with N and N prime. And the center of both those lines, that will be our line of reflection, which is x is equal to 7. Part 2. Draw triangle L prime, L double prime, M double prime, N double prime, a new triangle. The image of triangle LMN after a translation by the vector 0, minus 3. So if this is being translated, it means it's being slid, or it's sliding down. So it's moving 0, which means it's neither moving to the right or left, but moving minus 3 in the y direction. Means it's moving 3 units downwards. So let's slide it down. Name and describe a combination of two transformations which may be used to map triangle L double prime, M double prime, N double prime, our latest triangle, which is at the bottom left, onto triangle L prime, M prime, N prime, triangle on the top right. If we're starting with the triangle on the left base, we can slide it up. So to slide it up will be 0, 3, because it's not moving to the right or left, but it's moving 3 units up. And then we can reflect it about the line x equal to 7. So it will move from the bottom left, go up, and then slide to the right, and then flip to the right. This brings us to the end of CSEC past paper questions in the area of transformations. In this video, we've completed the past paper solutions from 2009 until 2013, and in our next video, we'll be looking at the next 5 years from 2014 until 2018. Don't forget to look at the description down below in order for you to get a better grasp of the entire math syllabus.